I saw this question on YouTube, and I have a different method to solve this equation, so I would like to share with you. While I'm using the complex numbers. So x is a complex number, which is r times cosine theta plus I sine theta. Okay. Then 1 over x is equal to 1 over r cosine theta minus I sine theta. Okay, then this equation we can rewrite as x minus 1 over x to the power of 6 is equal to 1. Right? Then we can write 1 minus 1 over x to the power of 6 is equal to 1, which means 1 minus 1 over r times cosine theta plus 1 over r, right, I times sine theta to the power of 6 is equal to 1. Okay. Now, since this complex number, the inside the bracket, 6 power equal to 1, therefore this complex number, the modulus must be equal to 1. So 1 minus 1 of r cosine square plus 1 over r square sine square is equal to 1. Yeah, because this side, inside the bracket, the complex number, the modulus must be equal to 1. Now this means 1 minus 2 over r cosine theta plus 1 over r square cosine square plus 1 over r square sine square theta is equal to 1. Now 1 and cancel out, and minus 2 over r cosine theta is equal to this plus this is equal to 1, therefore equal to minus 1 over r square. So cosine theta is equal to 1 over 2r, right? Yeah. So we have this. And then we plug this back into x, so x is equal to r, this is r, times 1 over 2r plus I sine theta. Yeah, this is equal to 1 over 2, yeah, plus I r theta. Okay, this tells us that the x we are looking for is a complex number. The real part is half, is constant, half. Okay, then the imaginary part is r times sine theta. Now, if we want to get rid of r, we can use the diagram. We can this is a complex number. This is x. This is x. And this is theta. This is half. This length is half. The real part is half. It's constant. Now, this is r, right? This is a modulus for x. And don't you think this imaginary part, this one is r times sine theta. But this is also equal to 1/2 times tangent theta. Okay. This is better because this one has no r. So our x now is equal to 1/2 plus I times half tangent theta. See, that is better. Although I haven't found x yet, but I know what looks like, x. X looks like this. The real part is half. Imaginary part is half tangent theta. Theta is my argument. See, it's very clear. Okay. I'll repeat again, okay? So far, for finding x, well, I haven't found x yet, but I know that x is a complex number looks like this. 1/2 plus half tangent theta I. Theta is my argument for x. Okay, so we're just looking for theta. We find x. Okay, once we find the theta, we find x. So our problem is now to find the theta. Okay, now let me continue. Okay, now this is a complex number of x. X must be there. This is half. Okay, this is half. See, just a matter of theta. X is here, or X is here, X is there, X on this vertical line. X. Okay, we are looking for X, right? X is this form, half real number, real part, and imaginary part is half tangent theta. Now, how to find theta? Then we have to use our equation from beginning. That is equation, right? X minus 1 to the power of 6. Yeah. X is on this vertical line. What is x minus 1? X minus 1 is equal to, well, x minus 1 is this minus 1. So this one equal to minus half plus I half tangent theta. Okay, this is my x minus 1. This is my x. So my x minus 1 must be there. This is minus half. Minus half, right? X minus 1 must be here. They share the same imaginary part. So if this is x, this will be x minus 1. If this is x. If x is there, this will be x minus 1. If x is there, this will be x minus 1, and so on. Okay. Now, this equation says that this complex number's 6th power equal to this complex number's 6th power. By using the Moore theorem, says that this complex number, this 6 times the argument. Now 6 times this argument is equal to 6 times that argument. This argument is theta. This argument is this angle, right? It's this angle. This is pi minus theta. So we get the information saying that 6 times this argument is equal to 6 times this argument. This argument is pi minus theta. Of course, the angle could be, adding multiple of 2 pi, right? N is an integer. So this equation gives us the theta. So now from which that we can find the theta is equal to pi over 6, 3 plus n. So as long as n theta satisfy our requirement. Now what's the requirement for theta? Since our x is on this vertical line, therefore theta must be between half pi and negative half pi, right? Not inclusive. See, x is there, therefore the theta must be from minus half pi to half pi. No, not inclusive. So this is the equation giving us the theta, right? Now, when theta is equal to 0, when n equal to 0, theta is equal to half pi. Well, half pi is not good, not allowed. Okay, n is equal to -1. Then theta is equal to 1/3 pi, right? That is okay. N equal to -2, theta is equal to 1/6 pi. That is okay. Let's see. N equal to -3, theta is equal to 0. Well, that is okay. N equal to -4, theta would be -6 pi, right? That is okay. N equal to -5, theta will be equal to -3 pi. This is okay. And n equal to -6, theta will be -half. That is not okay. That is not okay. And n cannot be positive. If n is positive, that theta will be more than half pi. This is not allowed. So these are angles we have. So our x is this, right? We just plug theta there, is -half. When theta when theta is 0, right? When theta is 0 is it's half. I'm talking about x, not x minus 1. I'm talking x. X is a half plus this, okay? And when theta is 6 pi, see, the plus or minus, half tangent 6 pi. When theta is this is equal to plus or minus half tangent pi over 3. Then if we put a number value for the angle, then this will be half plus or minus. Tangent 6 is a root 3, right? Tangent pi over 6 is a root 3 over 3. So this will be root 3 over 6. Yeah. And tangent third pi is a root 3. So this plus root 3 over 2. So these are 5 roots. 5 roots for this equation. Why 5, not 6? Because when you break up this bracket, the x6 power will be cancelled out. Leftover is a quintic equation. That means x to the power 5. Therefore, you have 5 roots. So these are 5 roots. Okay, this is a very nice method. This is a very nice method to solve the equation by using complex numbers. Okay, and I have other videos to solve this equation. One x to the power and x minus 4 to the 4th power equal to x to the 4th power. See, I have 2 more videos to solve these 2 equations. Now, if you're interested, you can find them, they are very nice questions to use complex numbers to solve the equations. Okay, thank you for your watching.